All right. All right. So to encourage folks to come into class, I'm gonna move my quizzes to the end of the lecture. And so I'm gonna also split them so they're more frequent, but they're smaller, so that I encourage you to come to class and do the lectures, right? So let's see. Yeah, so we'll do the quiz towards the end of the lecture. Is that okay? All right, so let's see where we left off. Right. So this week we started talking about servers, right? Creating HTTP servers to try and solve some of the limitations that we've encountered in just having a React.js applications, right? That we can't create a state that is permanent that can survive a refresh, right? On a client, right? If you add content, remove content, update content, if you refresh the browser, all your updates are gone, right? So the solution is to provide a more permanent state solution, right? That we're going to be using servers to do that, right? We're going to move all the state variables, all the data, the arrays, the objects that we've been using so far in React.js. We're going to move all that into a server, right? But then we need to make that data available to the client, right? And the way we do that is by creating HTTP routes, right? That we map all the data access, the data modifications, deletions. We map them to URLs, right? That then the React.js clients can then send these requests over to the server, and the server can then update the state and report how the state has changed. So yeah, we had started with that earlier this week, and we had started working on the fifth assignment that I had not made available, and now it is available. So let's take a look at it, and you'll notice that a lot of the exercises we worked on earlier this week, they're listed here, right? So this walks you through all the material that we covered earlier this week, right? About creating a Node application, installing NodeMon, right? Creating a simple hello world route that walks you through configuring Node.js ES6 so we can use the more modern import. We created a couple of simple routes, the hello route. We moved all these simple routes to the hello.js, right? And then we imported it so that we can then pass a reference to Express for that, right? So we worked on this. We also started looking at some of the first couple of labs, right? And all this source code is available, right? We worked on it earlier this week, and I'm going to push it to a Git repository and share with you. And again, feel free to use it as your own. So we created a lab 5 a function, right, where we're going to be hosting all various exercises, and also looked at how we can integrate it from our React.js application, which is a very simple integration. We're just creating just hyperlinks, right? Just links that if you click on those links, it navigates to the server, and the server responds, right? So it's not real integration, right? It was just a hyperlink. Might as well just type it at the command line, right? At the browser. We also discussed that there were 3 types of mechanisms for sending data from the browser over to the server. We said that we can either encode the data as part of the path, right? So that we can maybe encode parameters such as 2 and 5, right? As part of the path. We could do that. We also said that another way we can do it is to use query parameters, right? That we can instead of part of the path, we could use a query string, right? And then have an A equal B and A equal 5, B equal whatever, right? Separated by an ampersand. And then, which we'll see today, is passing data as a chunk of JSON, right? Encoded as JSON in the request body, right? So if it's large amounts of data, definitely that's the way to go, right? But if it's just a few things that you need to pass around, definitely path and query are an option, right? We went through several exercises of path parameters. We implemented a simple calculator that allowed us to just add and subtract, right? And then we created on the client side, we created a simple component that you could edit the values of A and B, and then send A and B over to the server, right? Encoding the values of A and B as a path parameter, right? And then the response came back as either addition or subtraction and whatnot. Okay. Then we did the same thing with query parameters, right? Where we built a small little calculator, right? That you can encode in the URL. You can encode not only A and B, but also an operation, right? Add, subtract, multiply, divide, right? And then the server could parse out those values from the query, and then this little switch case statement that depending on the operation, right, it returned the calculated arithmetic addition or subtraction. So a small little calculator. We implemented also a user interface, right, that encoded the parameters and the operation at the end of the URL, right, the calculator, and that added or subtracted, encoding added A's and B's, and then the hyperlinks to invoke the server. Then we played around with objects, right? We declared an assignment object, right? And we showed you how you could retrieve the data from the server, right? By creating a route that returned the JSON in the response, right? We discussed that there's the more generic version is .send, right? That is used for sending anything. But if you are certain that you're going to be sending back JSON, .json is a better option, right? We created a simple user interface to retrieve the object. We saw that we can retrieve an entire object or individual attributes. Here, for instance, we are retrieving just the title, right? But you could have additional routes that would allow you to ask for various different types of properties of the object. We also saw that we can implement routes that we could use for updating data in the server, right? For instance, this route that we built, took in as argument a new title of the object, and we saw that we could parse it out and then update the local object on the server, right? So again, we're exploring ways that the client React.js application can then interact with a Node HTTP server, right? And right now the interaction is that the client is just sending these URLs to the server, and then the server is reacting to that, right? It's handling these requests and modifying its internal state. Yes, right? We then explored, creating a little UI that allowed us to manipulate a remote object, right? That allowed us to maybe type in a new title and an input field, and then encode that new title, right, in the URLs, right, so that the server could then modify that from a user interface, right? Yeah, and then we started looking at arrays. I'm not sure if we got to arrays. Let me see where we got to earlier this week. Let's see. So this is prepping for A5. Let's let me store this. A5. So let me switch over to the A5 branch where we worked on earlier this week. Okay. So we were working on several exercises. These are the same exercises that we just looked at in the assignment 5, right? Working with objects. Again, this is available to you in the repository. I'll make it so that you can access it. Check out branch A5, right? And you'll find there the user interface for the React.js. You'll find the code also on the server side, right? Actually, there will be 2 repositories, right? Remember, we're using 2 entirely different repositories. One has the React.js source code, right? And there's a completely different a source repository for the server, right? And they have nothing to do with one another, other than they will be deployed on servers and they'll be talking to each other with HTTP, right? But as a source code, they are entirely separate, right? They're entirely separate processes. The only thing that they know about each other is that one knows the URL of the other. That is the only thing that they're somehow related. Okay. Yeah. So that's the React. So the other project is the Node.js project, right? Let's see. There it is. It's Canvas, Node, Server, App, CS4550. Let's bring that up. Oh, I need to open it as a separate window. Just a minute. Open new window so I can have them both running simultaneously. At the end of the lecture. Okay, so here we have the web app. This is the web app project. Yes, this is the web app project that we've been working for the last month or so, right? And all the exercises that we worked on earlier this week, right? Encoding parameters in the URL, working with objects. So let's start working now with something a little more interesting, like working with arrays, right? Or collections of data. Okay. Now on the server side, we've been here are the lab exercises that we've been playing around for the last day or so, last lecture, right? We have there's the object that we've been accessing from the server, right? So let's start the server. So we'll do nodemon app.js. So that's running, and then on React side, we can start the React side. So npm start. So now they're both running. The server is listening at port 4000, if you remember, okay? And the client it's still listening at port 3000. Yes, right. And again, there's nothing common to these other than the client knows where the server lives, right? That's the only thing that these two projects have in common. The client knows the IP address and the port number of the server, right? These are not projects that are one inside of the other, right? They don't share any source code whatsoever. Yes, they're entirely separate processes running, separated by this HTTP request. Also, they're being stored in completely different GitHub repositories, and they're eventually going to be deployed in completely different remote servers, right? We already have our React application running on Netlify, and eventually we will have our Node server running an entirely different server, right? We'll have choices maybe on deploying on AWS or Heroku or Render.js, and there's a whole bunch of free options, right? I'm going to be deploying to Render.js, but if you want to try out maybe AWS, that's also a great option. Heroku, I don't know, it used to be free. I don't know if it's free anymore. I think if you have like a Northeastern email, you can get like a free account, right? Or a free number of hours that you can deploy that and host it there for free. You're welcome to explore that option. I'm going to be using Render.js, right? And you're welcome to do that as well. So anyway, so we were looking at the labs, and we were working on lab 5, and lab 5, right? We were able to get the title or get the assignment object. So let's focus on something a little more interesting. Let's work on arrays, right? Okay, so let's do that. So assignment 5 walks you through, declaring a few objects inside of an array. And I'm going to use the example that I've been using for several weeks of just a simple set of to-dos, right? So I'm going to declare an array of to-dos in my server. Right? So I have an assignment, and now I'm going to have an array of to-dos, and I want to be able to retrieve these to-dos. So we can create a endpoint, right, that can retrieve the to-dos like this, right? And we can respond with JSON, respond.json, right? And then the to-dos. So now these should be available at that HTTP request route, right? And I can try it out here. I can say localhost 4000, right? And retrieve the to-dos. And there they are, right? So I can retrieve the to-dos, right? There they are. And so now, now there are a pretty standard set of operations when you're talking about collections, working with collections, right? Like an array, right? Or any set of data, whether it's a map or a set, right? Or a table that has many rows. There are a very well defined set of operations, right? That it's valuable to think about them as a very well known collection, and we refer to them usually as by their acronym, which is CRUD. CRUD, and stands for create, read, update, and delete. Right. So if you're thinking of any collection like a to-dos, it's good to think about what are the operations that are possible, and those are the four main operations. Right. We just implemented the R in CRUD. R means to read or to retrieve data, right? The entire collection, and here it is. We've implemented the first of the four operations, the CRUD operation. So this is the read operation. Now there's several other types of read operations. So for instance, this one is as the name suggests, retrieving the to-dos, and it's not specifying which to-do. See that? So presumably this is interpreted as meaning that I want to retrieve all the to-dos. Yes, right. Other CRUD operations, other read operations might be a little more specific, that I want to retrieve a particular to-do. Right? I only want to retrieve a single to-do. For instance, that if I give you the primary key of the to-do, right, then you will only return that particular to-do. You find it, and then you retrieve just that one to-do. Right. So if we try that now, and I give you the ID, say 3, right, it would come back with only that one to-do. Make sense? Right. And that's basically answers one of the questions we had earlier in our lecture earlier this week, is when would we use path parameters and when we would use query parameters? Yes, right, because it looked like we were using them arbitrarily, right, for doing calculations, calculators and adding and subtracting, and sometimes we were using path parameters and sometimes we were using query parameters. Correct? Well, in this context of working with data sets like this, right, there is a very well defined criteria of when would you use path parameters and when would you use query parameters. Okay, so the criteria is that if you are talking about a primary key, right, that identifies a specific object in a set, right, then you would use path parameters. Right? You would only pass an ID as a path parameter, not as a query parameter. Okay, and that's just it's kind of a convention, right? It doesn't have to be like that, but it's a very well-known convention in industry. If you are encoding primary keys, you use path parameters. If you are encoding anything else other than the primary key, then you would use a query parameter. Okay, so for instance, if I want to retrieve the to-dos, right, that are completed, right, I would not encode the URL. I would not encode completed in the path. I would use instead a query parameter. Make sense? Right. So let's try it. Say I want to retrieve all the to-dos that some of them are completed and some of them are not. So half of them are completed and some of them are not. And I want to query, give me all the completed to-dos, or give me the ones that are not completed. Yes. What URL would I use? Okay. One option is to do the following. I could do something like app.get completed, for instance, right? And so this would be an option. That would be an option. I could implement it like this, right? A5 to-do is completed, and it would come back the ones whose completed is true. Yes. But the point I'm trying to make is that this is not kosher. This is not how you would implement it, right? Instead, you would do something like this. You would want to be able to do something like, HTTP : localhost 4000, and then provide a query parameter for which you can then use to filter out the ones that are completed or not. Make sense? Right? So if you're implementing any arbitrary predicate, right, that you want to filter, right, then you would use query parameters. But if you're filtering by the primary key, you would use path parameter, right? So for instance, like examples, right? If you have an employee data set, right, and you want to query, and it says, well, retrieve for me who the employee whose employee ID is 123. Then the URL that you would use would be a path parameter. But if you want to query things such as, well, give me the employees who have in this salary range and are in the engineering department, and their boss is blah blah blah, whatever, then that query you would not use the path parameter to include those parameters. Instead, you would use a query string. Make sense? Right? Again, it's a very well-known convention, right? And oftentimes it goes under the moniker of RESTful APIs, right? So RESTful, REST, it's an acronym. It's I forget what it stands for. And request transfer, state transfer. Okay, I forget what the R stands for. But it's a set of conventions, right? That state that the IDs are encoded in paths, query parameters are encoded, other predicates are encoded in the query parameters, and your URLs should only include nouns, not verbs. Okay, it should include nouns. So again, it's a set of naming conventions, right? That the industry has found to be useful. Okay, so how would I implement this? Representational state transfer. That's what REST stands for. Go ahead. So for instance, if you want to create, right, if you want to create a to-do, you would be tempted at using a URL that would say /todos/create, right? So that would be a verb. So that would be a no-no. Right? So instead, you would use a app.post, right? And post would be the verb of creating new things, right? Or if you want to remove something, you might be tempted at doing, /todo/delete, okay? Which we're gonna do. We're gonna do in a minute, okay? But the RESTful set of conventions, would say no, don't do that. Instead, right, use the correct HTML, HTTP method. Okay, but we'll do that. We'll take a look at it in a minute. Let's first look at this. Okay, so here I want to filter by completed. It's a query, so I would filter it out. I would say completed from the query, and excuse me. If there is a flag of completed, then I'm going to filter it. I'm going to grab all the to-dos are completed. I'm going to respond with the completed, and I'm going to return right away. If there is no completed flag, means that you want to just return all the to-dos. Make sense? Right? So if there is a completed, meaning if there's a query, if I provide the query, then this is not null. It's either true or false. But if I don't provide the query, then completed is undefined, and I would not do this. Instead, I would just respond with all the to-dos. Make sense? Right? I also need to make sure, let's see, completed. So completed is a string, right? It's a string. So that means that, let's see, if completed equals, if completed is true, then I return this. Else, if completed is false, right, I return the not completed return. and otherwise I return just all the to-dos. Okay, so let's try it out, see if it blows up. Okay, so if I say to-dos, this still returns all the to-dos. But if I say, you know, completed true, it returns only the ones who the completed is true. Or if I say false, right, it returns the ones that are false. Make sense? Everybody good? Right. Of course, I'm using just a single filter property, but I could have multiple properties, right? You can imagine that if these to-dos had other properties, maybe like due dates, right? You know, who's assigned to, there could be a whole bunch of other properties here. And I might want to query the multiple properties. I might say, well, the ones that are completed, but are due next month and are assigned to Alice, right? Okay. So you would you know, you would query, you would parse all the other things, you know, maybe the due date, also the assigned to, right? If you had other fields here, right? And then it would be your responsibility to implement, right? How you would filter out, right, and iterate over the arrays, looking for the and fulfill the query. Make sense? Right? Obviously, I'm not going to implement that, but you understand what I'm saying. Yes. Okay. Okay. So let's keep going. Yeah. So all the to-dos, we retrieve a to-do by its ID. And here, you know, complete by the query string. I think my implementation here was a little more compact. There's also the user interface. I'm not going to create the user interface, right? You can do that. You can copy from here and implement the user interface. I really want to move forward. What about creating new items in the array? Okay, so I just said that in a RESTful API, you would not use verbs, right? That actually comes a little later in the assignment. First, let's misuse this. And the reason I'm going to misuse this is that the get request, .get request, is the easiest to work with, right? Because you can just type the URL right here at the command at the browser URL field, right? You could just type it up, right? And you're generating get requests. All these are get requests. They're going out to the server, right? If you inspect and you look at the network tab, if you look at the network tab, right? If I refresh, you'll notice that all these are get requests. See that? There are other methods such as post, put, delete that you cannot generate right here from the URL. Unfortunately, you can't. You need, you know, tools such as Postman, or have to actually write JavaScript that generates posts, puts, deletes. So for now, let's keep it simple. I'm going to misuse the get. The get, as the name suggests, is strictly for retrieving data, right? Not for creating data. But for now, I'm gonna misuse it. So let me copy that. So let's create here. So this create, to-dos create. So if I send a create, it's going to instantiate a brand new to-do. It's going to give it a random primary key. It'll give it a default title, and it's going to push it to my local arrays of to-dos, right? And then it's going to respond with all the to-dos. Let's try it out. Let's try it out. So if I say here to-dos and say create, okay, notice that indeed the last to-do here was created and appended to the array of to-dos, right? If I run it again, it'll add another one, right? If I run it again, it'll add another one, all with random primary keys. Everybody good? Okay. Also notice that I declared this get request. I declared it before this route. See that? I did that intentionally. If I did it the other way around, this would not work. Okay. Notice if let's move this up, this above, right? If I move this before this, like that, right? It's not going to work. Let's see. Let's do a create now. Notice that my server, I think, might have crashed. let's see. Okay, it didn't crash, but the response, there is no response. The server did not respond. Why did it not respond? And it's because, notice the pattern of this URL, and notice the pattern of this URL. See that? Both have the pattern of starting with A5, then to-dos, and then something at the end, right? So this pattern here includes the pattern of create. See that? And because it's declared earlier, right? The Express is going to compare the URL against this pattern first. Yes? Right? And because this URL matches that pattern, it's not going to bother checking for this one because it already matched this. See that? Right? So the order of declaration of the routes matters. Right? Now, the reason it works the other way around, is that if it matches exactly, /to-do/create, it does this, right? If it doesn't match exactly /create because I said something /to-dos/3, right? It doesn't match the first one, but it matches the second one. See that? Right. So Express iterates over the URLs, the pattern matching in the order in which they're declared, right? So it will happen from time to time where you create routes, you're working with hundreds of routes in your application, right? And you're hitting your server with a URL that you're certain is correct, and it's not doing what you expect, right? And so consider that there might be URLs that, right, are colliding with one another, right? And that there is an order of declaration that matters, right? So revisit your URLs to see if they are declared in the right order. Yes? All right. Okay, so let's so now it should work. There it is, right? So create it. Right, so wait a minute, what happened to my other tasks that I had created earlier? Where'd they go? I know I created a few more. I thought there was these servers remembered. Well, because I changed the code in my server, NodeMon restarted the server and reset the state. Yes, right. So it's expected. It's expected, right? Okay. So what about maybe deleting from an array? Again, I am misusing the get requests, right, and putting verbs in here. Eventually, these will go away, and these will go away, and they will be here, right? But not yet. Okay, so for delete, notice that what we're going to do is that we're going to first identify which to-do you want to remove, right? And then we'll give you the command to delete it, right? And basically, it'll be just finding the to-do, where it is, and then it's going to splice it out from my array. Pretty simple, right? So if I want to splice out maybe number 3 here, I can identify number 3. There's 3 right there, and I'm going to delete. And then it comes back, right, with all the to-dos, surviving to-dos that I have not deleted. Everybody good? Okay. How about if I want to modify a particular to-do? Right, maybe I want to update a to-do. And so, for instance, I want to modify a title, the title of a particular to-do. Right, so it could be implemented, as in, again, identify the to-dos, and then provide the property that I want to modify, and then the new value, right? And again, I can just find the to-do by its primary key. Once I find it, I can override the title with the new property that I passed in, right? And then it just returns all the to-dos, right? So let's play around with that. So here are all the to-dos. Here are all the to-dos, and say I want to modify task number 2, right? Which has just task 2 here. So I can modify, I can return to, and I can change the title, right, to make dinner, right? And then it comes back with that particular to-do being modified. Everybody good? Yeah. All right. So basically, we can do all the CRUD operations. We can create new data. We can retrieve data, either by ID or by some arbitrary predicate. We can delete data. We can update data. All the basic CRUD operations, right? All right. But right, there hasn't been real integration. Right? All these URLs, from the user interface, right, is it's just basically a hyperlink. You click on it, you fire away this URL. The server changes, but there is no feedback to the user interface. Yes, right. There's still kind of two things separated, right, by this HTTP chasm. So how can we integrate? Really integrate? Okay. So to integrate, what we really want to be able to do is these React applications, right? Yes, making the request out to the server, but instead of just navigating to the server, I want to stay within my React application. I don't want to leave my React application. What I want to do is behind the scenes, go out to the server, capture the response from the server, and then update the user interface accordingly. Okay. All right. So how do we do that? Instead of just navigating here. Yes, I want to do this, but I want to do this like behind the scenes without me literally leaving my React application and going out to somewhere else, right? I don't want to leave the comfort of my React application, right? So how do we do that? So what we're going to do is that we're going to use a technology called AJAX, right? Or asynchronous JavaScript and XML, right? So it's a technology that developed in the late 90s, at the end of the last century, where we wanted to have JavaScript be able to send requests out to a server asynchronously behind the scenes, right, without leaving the actual HTML page, right? And way back when, at the end of last century, the preferred data format was XML, right? And so everybody was working with XML. Lots and lots of pointy brackets everywhere, and the big companies, Oracle and the IBMs and the Microsofts, they were all betting right on the future of this technology. So the name stuck, right? The XML. Today we rarely use it for XML. Okay. Instead, we use it for the most common data exchange format is JSON, right? And the reason is that most of the clients, most of the clients are web-based clients that are using JavaScript. So the data format that is most convenient, right, is a data format that is already written in the language of preference, right? So JSON has overtaken XML as the preferred data format. Anyway, so to be able to talk and use this new technology, the AJAX technology, we're going to be using a library called Axios, right? Which we need to install on our web side. So back on the web application, we're going to do npm install Axios. So that's going to install on our React side. And now Axios is going to allow us to do these requests that we have been typing. We're going to be able to do them programmatically, right? We're going to say, hey, Axios, send this GET request to the server and capture the response, right? And then you can use it inside a React application without leaving the React application. All right, so let's do that. Let's play around with that. So we have Axios, and now that we have Axios, let's try it. So for instance, let's do something trivial. We already have a welcome here, I believe. No, do we have welcome? Yeah, we have welcome. I would like to just grab this string, right? Grab it from the server and then just display this in the React application. I can't do that right now, right? So but now that we have Axios, we have a fighting chance, right? So let's go back to our index here, and let's just grab that. Let's grab that. So encoding, where are we doing this exercise? Right, encoding. Yeah, so let's do it in here. Encoding parameters in the URL. And so let's So let's try and grab that message, right? And so now that we're going to go fetch this data from the server, we're going to need a placeholder to store it here on the user interface. Yes, and then have it render actually on the client on the React. So let's create a state variable that will contain the welcome message, right? Which is empty right now. And let's try it out. We'll do h4 the welcome message. So we're going to render the welcome message like that. And let's see if we can, I need to restart probably the server, npm start. So here's my welcome component, which is right now it's empty, right? And message before server. So here's my message before getting it from the server, yes? But we're gonna go fetch it from the server, meaning we're gonna do this query, fetch this text from the server, and we're gonna populate that state variable. And once we populate the state variable, it's gonna render right here. Okay, so let's do that. Something really, really trivial. Okay, so how do we do that? First, we're gonna create a little function that's going to fetch the information. We're gonna say const fetch welcome message. Okay, and we're gonna use Axios. So we're gonna import Axios. Okay, and we're gonna use Axios as follows. We're gonna say const response. Axios is gonna do the welcome. There it is, the A5 welcome. It's this URL, right? It's this URL right there. It's the same URL. I'm just gonna copy it, and I'm gonna paste it right here. Yeah, it's that URL. So let's see that. All right, so we have the function. Let's invoke that function. When should we invoke that function? How should we call it? I guess we can call it like that, right? Let's see if that works. Let's refresh. So something is not working. Let's look at the console here. Okay, notice that the console is complaining, saying something is amiss. It says that you are trying to communicate with localhost 4000 A5 welcome, right? And it's complaining of a no access control allowed origin. See that? Right? The browser has identified a security problem, right? It says, wait a minute, you are running on localhost 3000 and you're trying to communicate with somebody who's running on localhost 4000, right? The browser is interpreting this as a cross-domain request, and that's not allowed, for security purposes, right? JavaScript files are only allowed to talk to the server where they were downloaded from, right? So they can only talk to anything that is running on localhost 3000, right? Not anyone else. Yes, right? And the way it works is that the browser goes out to the server that you're trying to talk to and says, hey, so this script that is hosted at some other domain is trying to communicate with you. Is that okay? Right? And the server can, by default, the server will say, no, I don't know that other server. So no, I'm not going to allow the communication, right? And the browser just shuts us down. Okay. We need to configure the server to allow these communication. We're going to say, we can whitelist and say, hey, if you receive communications from these particular domains, then let it go through, right? Or right, if you get it from these other domains, then don't let it go through. Or we can be optimistic and say, let anybody in, just let anybody come in. I don't care, right? So let's do that. Let's do that for now. So let's go back to the server. And in app.js, we're going to need to configure and tell the browser that it's okay, right? We trust whoever, I don't care. Come in and get all the information you want. For that, we're going to need a particular library. So I'm going to stop this. And the library is called CORS. CORS stands for cross-origin resource sharing, right? And it's a protocol that allows you to configure security on who's allowed to read what, okay, under what conditions and whatnot. Okay, so let's install that. Let's import it. Okay, and the way you use it is by doing that, just that. You can say app.use course, right? So remember, we've been using app.get, app.whatever. Remember that, right? That's what we've been using. Well, there is a broad request, right? That you can configure. That this says that for all requests, not just get requests or post requests or delete requests or put requests, for all requests, right? Make sure to have course take a look at it, right? And by default, if you don't provide any configuration, if you just say course and you don't specify any configuration, the default is to allow anybody in, right? To disregard any security measures whatsoever. We're going to open up ourselves to anyone who wants to communicate with us, all right? Later on, we're going to come back to this. And when we look at logging in and username and password and things like that, we'll come back to this and say, wait a minute, no, maybe we need to narrow it down a little bit, okay? All right. But for now, let's do something trivial. We're just going to open up ourselves to anybody who wants to come in, all right? So let's start the server again. And let's go back to our client, and there it is. So now it's not complaint. Now we're not getting the error anymore, right? We're not getting the error anymore. If we look at the network tab, okay, we did go out. Notice that we did do the requests. See that? There it is. Our URL went through. It went through. Okay. So that's great. It went through. We need to now grab the response. Grab this response. All right. So let's print out what the response is. Let's do a console response, right? So let's refresh and look at the console. It's a promise. What is that? What is a promise? Okay, so the communication between JavaScript running on the browser and JavaScript running on the server is, in general, an asynchronous communication, right? And what we mean by asynchronous is that it's non-blocking, right? All throughout our careers and that we've been, learning about programming, we've been implementing source code that is synchronous. Synchronous in the meaning that when you execute your code, typically the way you read your code and you expect it to behave is that you execute line 1, then you execute line 2, line 3, and so on and so forth, from top to bottom, from left to right. Yes, right. That's not true over here. Okay. In asynchronous communication or asynchronous code, things don't necessarily happen in the order in which you program it, right? It's asynchronous, meaning that usually you would think that if you make a function call, right, from somewhere, you don't continue to the next line until the function comes back and does the return. Yes, right. That's how we've been taught to program, right, for the last several decade or so, right? You make a function call, and when it comes back, right, you have the result from that function, and then you can continue. Yes? Well, not here. Not here. This function call at that line is not synchronous. Okay? It's not going to stop and wait for the server to respond, right? And it's implemented that way because the dependencies between a computer running on the West Coast and another computer running on the East Coast, all right? If you create a hard dependency between the two computers, you run the risk of blocking, right, the computer that's trying to communicate, because the other computer might be down, or it might be that you sent a request but it never responded, right? Or it's taking way too long, or the network was down. Way too many things could go wrong between the communication of one of the computers and the other, right? The browser talking to a server, right? A browser running on the East Coast with a server running on the West Coast, yes? right? Way too many things could go wrong. So the way we program this is asynchronous, meaning don't block, right? Because you could be waiting here a long time, right? Instead, send me the request, but then go on and do other things, right? Maybe you have some animations to work on, right? Or some video to streams, or don't block the single thread that is trying to run through here. Make sense, right? So what we get is instead a promise object. That's what comes back from requests, not the response, but a promise. So promises are a mechanism in JavaScript that allows us to deal with asynchronous communication. Right. The way it works is that the GET request comes back with an object which is of type promise that you can then register a callback. Right. You can say, hey, I'm not done yet. Right. I'm working on it on your request. Okay. But I don't have a response for you just yet. Right. Go do something else. Leave me a phone number and I'll call you when it's done. All right. And so the JavaScript on the browser says, oh, okay, well, here's my phone number. Call me back, right, when you're done. Okay. And then I'll go do something else. Right. I need I have to stream cat videos or whatever. Right. I need to do some animations and whatnot. Right. So really I have here a promise. This is what I get, a promise. And the way it works is as follows. The way it works is as follows. So I'm going to first show you the old way of doing this, and then I'll show you the new way of doing it. Okay, because the old way is still widely used, and you'll find a lot of documentation, right? And then I don't want you reading old documentation and says, "What is this? I've never seen this." Okay, so I'll show you the old way of doing this, right? And then I'll show you the new modern way of doing it. Okay, the old way is hard to follow. Okay, so just hold on with me. Right, we'll do it step by step, and then I'll just throw it away, right? And so that there's at least once that you've seen this, okay? But then I'll show you the new syntax, and then we'll all breathe a sigh of relief that we don't have to do it the old way, okay? All right. So how does it work? So the old way is that we get the promise. Okay, there's a chat here. Is it all right to say no? Don't take the quiz now. No. Right. So the way it works is that the promise object that comes back has a function called .then. See the .then, right? The .then, it allows us to register a callback, right? Register a callback saying, hey, I know you're working on it. When you're done, please call me back. And the way we do that is by using the .then. In the .then, we can provide a function in here. We can provide a function. This is a callback function that will be invoked at some later time, right? Once the actual response comes back from the server. Meanwhile, I'm free to go do some other things, right? At a later time, the response will come back, and then we can print out the response. We can print out the response, right? So this function here will be invoked later, maybe half a second later, maybe a second later, maybe a minute later, okay? I don't know. At some point in the future, it will be invoked with the actual response that came back from the server. Everybody good? Right, so let's print it out. Let's print it out. Okay, there it is, right? I'm gonna refresh. There's the data. Look at that. See that? This is what's actually coming back from the server. It's telling us that the request was successful, right? That the headers that I sent over, these are the headers that I sent, including cookies and whatnot, a whole bunch of stuff. The response that came back, the headers from the server, right? And the actual data. This is the data, right? The string that I'm sending back from the server. See that, right? So most of the times, I'm only really caring about the data, right? I don't care about the other stuff. The other stuff is just a whole bunch of meta information that most of the times I don't care about, right? But the data I do care. So I can now set the welcome message to the response.data. And there it is. See that? That is the data that came back from the server. See that? Yeah. If I change it on the server, so I change it on the server, right? And my hello here, and I change this to was it hello? No, it was oh, it was lap 5, right? Lap 5 welcome. Lap 5 welcome. Here, here's welcome to assignment 5, right? There it is, welcome to assignment 5. But if I change it, say, I don't know, I put just a like that, right? And I just refresh. There it is, right? I'm getting the data from the server. You see that? Right? As opposed to you're actually going to the URL, right? And fetching it like this. Here, I never left the user interface. I'm always here in the React application, and I never left. I stayed within my React application. Everybody good? That makes sense? Right? Okay. So yeah. So the this is what we mean by communicating with the server asynchronously and receiving a response, capturing the response, and then using that response to update the user interface. Yes? You know, without actually navigating away from a React application. Okay. All right, but this syntax looks awful, right? This syntax looks horrendous, right? So let me show you a better syntax, a more modern syntax, which hopefully will look much more familiar to you, right? And you'll be able to follow along easier, right? So I'm going to comment out this. So I'm going to do the same thing, but using the new syntax. So the new syntax is what we want is something that looks like this. This is what we want. Here's the response equal Axios, right? And then and I want to be able to say set welcome message response.data. That's what I want. Not this ugly .then and promise and garbage, okay? We want something that looks more like this. I'm going to go out to get that. I get the response back from the server, and I know that the data is in the response.data. Boom, I'm done, okay? Unfortunately, the get is actually responding with a promise, and I have to do the .then, and oh, it's awful, okay? Well, we can do this. We can use this if we just remember to use the following syntax, okay? If we remember the following syntax, we can put an await here and an async right there. If we do that, then it behaves as we expect, right? So if I save this, and I refresh, notice that this is working as expected. See that? If we just remember that, we don't have to go through the garbage of using promises and the .then and putting a callback function and all that, okay? All right? So what you'll see in the assignments, you'll see that I'm using a combination of both. You know, sometimes you'll see me use the .then, and sometimes you'll see me use the async await, right? Some exercises use the new syntax using the async await. In some other examples, you'll see me use the older promise .then. Yes. Yeah, excellent. So yeah, you use the new syntax, right? The old syntax, right, is you have a .then and you have a .error, right? And you handle the error here. That's the old syntax, right? The new syntax is that you use just regular try-catch blocks, right? So you do try, right, and then you catch here, like that, which is great, right? Because it's the same syntax you would use regularly in JavaScript, just to try catch, right? Actually, you have a couple exercises in the assignment. I think they're optional or extra credit that ask you to handle errors, right? And wrapping this instead of a try catch, especially like if you ask for a to-do list, a to-do item with an ID that doesn't exist, what do? Right? You need to be able to handle those errors, right? And say, oh, I can't find the to-do with that ID, right? So how do you handle that? So definitely with a try catch. Yeah, excellent. Yeah, so let's keep going. Fetch. All right, so All right, so I'm calling this function like this, and you might say, well, why even bother having a function? Couldn't we just have this at the top of the declaration, right? And not even bother putting it inside of a function. But because we are using async, right, it needs to be inside of a function. All right. The other thing that's going to happen is that if you remember, I mentioned that React.js uses a virtual DOM, right? And once the component renders, you know, in its first pass, right? If anything changes, all right, you need state variables to modify these and whatnot, right? So to deal with stage changes, the appropriate thing to do if you're doing, let me say, later, the appropriate thing to do for setting up an initial state, especially if it's state that depends on a third-party API, the appropriate thing to do is to use the sister of the useState, right, function, which is called useEffect. So useEffect is an equivalent to useState, right, which is used, right, to initialize the state of an application of a component. Right? So if you have to go out to a server and do a whole bunch of queries and do data updates, and once you get the results of all those things, you get back the results, right? That should be done at the useEffect function. It works as if it were like a constructor, right? Like in a constructor, typically what you would do is that you would set up all the state variables, right? You would initialize everything, right? And once the constructor runs and you set up the correct state of the object, then you can continue, right? Typically, that's what you do in a constructor. Well, useEffect plays the same role. Plays the role of first do this and then render the component. Okay, this is a chance to give you of updating things, and also you have this this square bracket at the end that we're not going to see just yet, but this allows you to configure dependencies, right? That if things change, maybe the ID of the course, or maybe a parameter or some state variable, that if it changes, then this whole thing should run again, right? Because I need to re-establish the state because something changed. You change the some attribute, maybe some ID, and because you change that ID, I have to go fetch the state again, right? I have to reset. I am not depending on anything because nothing is changing. Nothing is changing, so I have no dependency, so it's an empty array. Okay. So yeah, so the proper thing is to set the fetch, any updates at the beginning using useEffect. Okay. Yes. No. So useState, so the initialization of these states, if you want to modify them and update them at load time, on load, right? You would use the useState and call them from within useEffect, and that's exactly what we're doing, right? We're calling this function, and this function eventually is setting the state here. See that? So they would use them in tandem. So useEffect is where you would do the initialization of your state variables, right? If those state variables depend on some remote data. If they depend on some constants, then you don't need to, right? Or they could depend on arguments that you pass in as parameters of the function, then you don't need the useEffect. But if these variables depend on data that lives on a server, right, then I have to go fetch it, and once I have it, then I can set the state. The convention is to do that within useEffect. Okay. Right. So you use useEffect to establish all the dependencies, all the remote dependencies. Okay. Yeah, no. So I'm going to move the quiz to later, and so I'm going to do is I'm going to now have them at the end of the lecture, and I'm going to split them up so that they're more frequent, so that you have an incentive to actually be here present at the lecture. Yes. Yes. Maybe. Okay, so right, so we retrieved that. So let's play around with this idea a little more. Right, so we retrieved just a simple string. We configured course. We retrieved just a simple a text. How about maybe objects or arrays? So let's go fetch the array. Let's go fetch the array. Let's do that. Right. So let's go to our working with arrays here. And we have our React application here working with arrays. Working with arrays. Oh, objects. Oh, I don't have a working with arrays. So let's create a component where we can play around with that array. So let's create here a new working with arrays. So we'll do function working with arrays. And why are you adding all these classes? There's a H2. And let's do export working with arrays. And let's bring that into our lab here. So this will be working with arrays. Oops. With arrays. There we go. So there it is. So working with arrays. So let's go fetch the array, right? So we have the array that we can say to-dos here. So to-dos, there they are. So I'm gonna go, I want to fetch them using our new, Ajax technique, right? So in working with arrays, perhaps I can create a little array here that can hold the data. So this will be, this would be the array, the to-dos, right? The to-dos, and we'll say set to-dos. And at first it'll be empty, so no to-dos. That's great, not having to do anything. So we have here's use state, and also I'm going to need use effect, right? Because what I want to be able to do is use Axios. I want to use Axios to fetch the to-dos. It says fetch the to-dos using an asynchronous call that is going to do const response. There it is. So that's the query. That's exactly the query that retrieves all the to-dos. See that, right? Once I have the to-dos, right, I'm going to set the to-dos with what's in the data, because the data contains the array of the to-dos. See that, right? And then I'm just going to display that, right? And I'm going to run that fetch to-do on the use effect. Call the fetch to-dos, right? And I'm going to just display them here, right? So I can do pre and then JSON dot stringify, and then this is the to-dos null and 2. So if I go back to my client, there it is. There's my React.js application with the array, right, that it fetched, from the server. See that, right? So now the user interface is fully integrated with the client. See that, as opposed to just making a URL call, right, and just navigating to what the server says. Here, I never left the user interface. I have full control of this. I can render it any way I want. Right? I can say that I can use UL with a list group, right? That has I'm going to map over this li the item, the title. There it is, right? So and then I can render them as ULs. Yes. Okay. How about other things that we were able to do? We were able to create new to-dos, right? So if I have a button here to create, it says button, that class primary that create a to do, create. I have the button. So we would need a function that would allow us to create the button, right? The to do. So this would be what? Const create to do. But we have a URL for that, don't we? We have a URL for that called /to-do/create, don't we? So we would like to be able to invoke this, yeah? Invoke this, but when we click on that button. So let's do that. So this is the URL. Let's copy that. And we'll do, const response and await. And the URL is to-do's create, right? Actually, we're using get, not post yet, not yet. We're not using post just yet. Do the create. The response is going to do, in the response is the data, right? So set to-dos like that, right? And we're going to call the create to-do every time we click on create to-do. So let's go back, right? And oops, what's going on? Immer, blah, 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 blah. Missing module. What am I missing? Set? Oh, no. Okay, there it is. So notice that if I click on create to do, it's updating the user interface. See that right away, right? Without me going anywhere out there, right? So they're fully integrated, right? They're fully integrated. And if I want to delete, right, I can maybe put a button here. And this is const, delete to do. I'll pass in some ID, and the URL. Yeah, that's the correct URL. And I'm expecting the to-dos to come back, and I can set the new to-dos, right? So let's put here a button, right? That class button danger, right? That when I click on it, so this is the delete, right? So next to each one, delete danger. There it is, and maybe we can put it at the end. So float it to the end. So it's on the right, so that if I click on it, it deletes it. Yes. So let's do that. So this will be, if I click on it, it would invoke, on click. It would invoke the ID, pass into delete to do. Right. I'll pass in the to-do.id, which is going to be used to send the delete. And the response is going to contain the surviving to-dos. And I'm going to update the user interface with a new list of to-dos. Yes. So if I do that and if I click on this, right, I can delete the to-dos, right, or create new ones. Everybody good? Are still with me? All right. But, right, we're still misusing the get, right? We're still using get for creation, and we're using get for deletion, right? And that's a no-no, right? We should not be using verbs in the URLs, right? Not if we want to say that we are abiding by the RESTful API convention, right? If you find a lot of APIs out there, they say that they're RESTful, but they're not really. They don't abide by the conventions, right? And they're very well defined, right? If you're going to put anything in the path, it should be nouns, right, and primary keys, nothing else, right? If you're going to retrieve something from the server, you use HTTP GET. If you're going to create new things on the server, you use HTTP POST. If you're going to delete something, you use HTTP delete. If you're going to modify something, you would use HTTP put. Okay, so let's do that. Let's abide by the true RESTful API. So let's go back to the server and let's change a few things. Let's see. So the ones that are here are not RESTful. So this create is not RESTful because it has a noun on it. Okay, so let's create a RESTful version of this. Okay, so this should be post if we want to create something, right? Okay. Okay, now at least my URL is RESTful. I don't have the noun, the verb, right? Instead, the verb is right here, post. Okay? Post means to create content on the server, right? I am sending you data, right? And I want you to create this data that I sent you. I want you to add it to the collection, right? And which collection is the to-dos collection, right? So that's also a RESTful convention. The nouns tell you what it is that you are modifying, adding to, deleting from, right? Updating. Okay. So how do we do that? So, and the data that I want you to add will be embedded inside of the body, including any properties that I want you to add, maybe titles, whether it was completed by default, blah, 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 anything, right? The server can tweak the data before actually adding it, right? For instance, it might create a primary key, right? Because the user interface should not create primary keys. It should be the server or the database. It might add some default values, okay? And then push it, and then add it, okay? Okay. So the body is going to contain all the data, not only the title. So I want to have all the data. So I'm actually going to grab all the data that comes from the body, which might include title, completed. So all this data here is going to come from the client. Only the primary key is going to be created by the server, right? Everything else I'm going to provide here. So I'm not going to use this. So the data comes from the request from the body, right? So the body is when an HTTP request goes out to the server, again, you can pass data in the URL, right, as path parameters, as query, or you can attach documents. You can attach images, you can attach PDF documents, right, and upload them to the server, yes? Well, all that things that you are uploading, that goes into the body of the HTTP request, yes? And you can put anything in the body, right? Again, most times the cases where we have used it quite a bit, I imagine, right, is when we post a selfie or when we upload a document for an assignment or something, yes? So all that gets attached to the body of the HTTP request, yes? But not only documents, you could also just send plain text, as the attachment, right? But all that goes into the body, and it's available on the server at request.body, just like request.params or request.query. Well, request.body is whatever you attach to the body. This could have been a PDF document, could have been an image. I know that what I'm going to be sending is a string representing a JSON object, right? That for me, the meaning is that it's a new to-do. It's going to have a title. It's going to have maybe a complete flag. I'm gonna spread it into this new to-do. I'm going to add a primary key, and I'm going to add it to the to-do. Yes, everybody good? All right, let's try it out. Let's try it out. So going back to my user interface, this create to-do doesn't work, right? The new to-do would look something like this. I'm not going to use that. I'm going to use my brand new API. I'm going to leave that alone. So instead, I'm going to do a post right here, post. See that? Right? I'm going to send a post because on the server, I am expecting a post. Right? I'm expecting a post, and that's exactly what I'm going to send. But also, the server's expecting some data. It's expecting for me to send something. Right? So how do I send something? Well, the post, Axios post, has a second argument. And the second argument is the data that I want to send, right? And I'm going to send a JSON object that has a title of new to do and a completed as false. Everybody good? Okay, I'm going to send that as default. Obviously, this could be more interesting. I could have a form, right, that you can type in the title and and check the checkbox as completed or not, and then I can grab that as a JSON object and send that as opposed to this hard-coded JSON. Yes, actually, I think that's what the assignment asks you to do. create a little input field, right, where you can type the title of the to-do, right? You can, check a few boxes, and then that JSON object is what's sent over. Actually, maybe that's a good idea. We can say const a to-do, set to-do, and you can have a default state variable that has this like that. I think this is what the assignment asks you to do, and then this would be just to do. So now you can put like a form that edits the to do object. See that, right? And then you can send that over. Okay, so let's see if it works. Let's go back and see if there's a to do, and it's empty. Huh? What? Title completed. And all right, so let's see what the network. See the network. What's going on? Let's clear that up. Let's say send the create to do. You can see exactly what we sent. Okay. Oh, so to point out something, notice that there's two queries here. See that? One of them, look at the request method. See that options, right? That options, that's course, right? This is the browser going out to the server saying, hey, this JavaScript is running on port 3000, right? And it's trying to talk to you at port 4000. Is it okay? Right? What are my options? This is what the browser is asking the server, and the server responds saying, "I give you access to do get, head, put, post, delete, whatever you want." See that? Right? It's responding saying, "These are the options. You can do anything. You can delete. You can create. You can update. You can retrieve. I'm giving you all access." Right? Instead, later on when we play around with a little more with course, we can respond with maybe just get, right? And get would only give you a read-only access, right? I'm not accepting post, I'm not accepting put, I'm not accepting delete. This is read-only. You can only view data. You can't change anything, right? But this one is saying, again, the default that we configured was that I'm allowing you to do anything. All right, the actual query, if it sees these options and then realizes that you're sending a post, here's my post, there it is. If it's in the access control, then it'll let it go through. The browser will let it go through, right? If it's not in that control access, then it would block this, and we would get an ugly access control course, blah blah blah, saying you can't do that, right? Anyway. What are we sending? We can see the payload. This is what I'm sending to the server. I am sending a title. I am sending a complete. And the response from the server is I'm only getting the IDs. So it's totally ignoring my title. It's ignoring my complete. It's only creating the IDs on the server, right? So it's totally not working. So what's going on? Well, what's going on is that I expected that. By default, Express doesn't know what to do with the body. Right? By default, yes, I know you can send me a body, but there's many types of bodies, right? It could be a PDF document, right? It could be an image. There's many things that you can include in the body, yes? Right? So each data type needs a different mechanism of consuming that content, right? If it's an image, right, I need to be able to parse the image. If it's a file, right, I need to be able to parse binary and stream it and then write it to a file, right? We're sending JSON. So somehow we need to tell the server how to handle JSON, right? How to parse JSON from the body. And that's easy. We can turn on here a Express JSON. So Express JSON, right, it's a module in the Express library that knows how to parse strings that are formatted as JSON, right? And then provide that JSON in the body, to whoever wants it, right? So let's try it out. Let's refresh this, and notice that now it works, right? I mean, I'm sending the title of new to do, right, and the completed is working. Everybody good, right? Okay, so my post worked. So how about my delete? So the delete implementation would be that instead of using instead of misusing this as delete, right? The proper thing to do is instead to do this, do app.delete, right? And that has the URL, AI. Actually, let me just copy this. So it's this, right? But this is a delete, and no verbs in the URL, right? So that's the verb, right? And then we have the ID. It works the same way. We're doing exactly the same thing. It's just that now this is a RESTful API and this is not, right? Because this is abiding to a certain set of conventions, and this one is not. Okay, right? But obviously you can do either one, right? If you don't care to say that I am RESTful, right? So if I go back and re-implement the client, right? The implementation of the client is that instead of using this non-RESTful implementation, right? I would do something, const response dot delete. There it is, dot delete, and I'm providing the ID of the to-do at the end. See that? Now this is RESTful, okay? And it works the same way, right? So I can still create, I can still delete, right? Everything works the same way as before. Yes? Everybody good? Right? Okay, so there's one more thing that we're misusing. There's one more thing that was misusing. This creates to do on the server, where we're posting, where's our post? Post. Okay, so we are receiving data from the client. We are adding it, right? We're doing one thing wrong here. We are responding with all the to-dos. See that? Right, that's very expensive. Okay, if this is a very complex data structure or an array that contains hundreds of items, right, it would be very inefficient that just because we're adding one single item, you are responding with the entire array. Yes, that's very expensive and unnecessary, right? Especially because the client already has a cache copy of this array, right? Because it needed it for the rendering, correct? Right. So the efficient thing to do is that when you create new content, right, don't return everything. The only thing different from the old array and the new array is that there's this one additional object. Yes, that's the only important, interesting thing about creating something, right? So just return that. Just return that one to do. This new to do that you created is the only new thing here. There's no point in returning the whole thing. Yes? But if we do that, my user interface was expecting all the to-dos, right? Was expecting all the to-dos. So that needs to change here. So no longer no longer does the response contain all the to-dos. Now it only contains that one to-do. Yes? Right? So this needs to change to saying that now this is one single to-do. So that means that I need to update my user interface to match what's in the server. Yes? Right? So that we maintain some synchronicity. So I know that you added it at the end. I'll add it to the end myself as well. Okay? Right? And so we'll be in synchronous. So that you have this new to-do in your array, I'll have the same to-do in my array, right? So what I'll do is that I'll copy all the to-dos and I'll just append this new to-do at the end, just like you did on the server. See that? Obviously, this adds an additional challenge, right? Well, first, let's see if this works. Right, so let's refresh and let's create the to-dos. Okay, it works just like before, right? I'm adding this at the end. This works if I'm the only person creating to-dos, right? Because I'm adding, right, something to the array or the database, right? And I'm assuming I'm the only person who's creating data, right? And then it comes back and I add it to my local user interface. Yes? And for the most part, that works. If I'm adding my shopping cart, I'm the only one adding modifying my shopping cart, and you're modifying your shopping cart. As long as we're within our own context, it's okay, right? I'm adding my own little data structure, and you're adding your own little data structure. There is no inconsistency there. The problem is that if I'm adding stuff into the shopping cart, and my wife is also using the same account to also add stuff to the shopping cart, right? And so, I'll have things on the list that are different from what she might have because her user interface is different than my user interface, and has different context, right? So that we haven't dealt with. How do you work with shared data structures and that you have multiple users modifying the same data structure, right? In that case, we would need other mechanisms such as broadcasting changes over to the same user, saying, hey, this person added, like especially like in games, right, where everybody's moving around in a shared world, right, and everybody has to be notified, right, that you just blew up something, right, or you ran into some building or whatnot, right, and it has to be broadcasted, and everybody has to synchronize with the shared object. We haven't talked about that yet, right? But certainly it is something of interest if you have multiple users modifying the same data structure. Here, I'm assuming I'm the only person modifying this data structure. Yes? But it works, okay? So same thing with delete, right? In delete, the implementation of my delete is that I respond with all the to-dos. I'm responding with, and to make matters worse, right? These to-dos is smaller than the initial set of to-dos. It's missing now a to-do. So I'm sending you, information that is irrelevant, right? You already have this information on the client. Why even bother sending you the array of to-dos? You already have this to-dos. You just have to splice, just like I spliced it out from the server. You should also splice it out from the user interface to maintain synchronicity. Yes, right. So typically, the only thing that we send back here, because it's not worth sending anything, is some status, right? Maybe a success status saying, yeah, everything's good. I was able to do what you asked me to do, and you can send 200 or 204. 200 is a more common thing, but 204 means is that I'm just saying it's okay, and I don't have any further information. That's what 204 means. 200 usually would include maybe a message saying, yep, successfully deleted something or whatever, right? But 204 means I don't have any more information. It's successful. I did it. You might send you might send an error. You can send say if there's no to do, you would send a 404, right? That's the most famous status code, right? Sending a 404. I could not find what you're looking for, right? And then you would return. Okay. Otherwise, you splice it out and then you send it to a 4. So, but because we changed this on the server, on the client also it needs to change, right? No longer the data contains all the to-dos. Instead, I need to do what the server did, right? I need to splice out that particular to-do, right? So I can filter out. I can say to-dos filter so that the to-do is not the ID, right? Okay, so that would do that, right? I'm just filtering the to-do so that it's all the ones are not that ID, right? So that it gets removed from the user interface. Okay? So that if I come back here and I can create, I can still delete, right? And I'm maintaining synchronicity. I can always check to see if I get the to-dos. Notice that I have the same to-dos here on the server as I have on the client. Right? The client also has the same exact to-dos. Everybody good? And again, it's always a challenge now that you have data in two different places. You have data in the user interface, you have data on the server, right? And the normal thing you have to do is to maintain synchronicity between the two data structures. When we add the database, it's going to be even more challenging because the data is going to live in three places, right? It's going to live in the user interface, in the middle tier in the server, and it's going to live also in the database, right? And all three need to be synchronized and make sure that there's consistency between the three data representations, right? So yeah, that hold on for that. Maybe starting next week. Okay. All right. So working with arrays, we're able to delete. We were able to create, fetch items by their ID, update, right? And so here we added right? We added the express JSON, right, to the app.js so that we can parse the body. And we talked about, the various methods, right? Get, post, put, post for creating, put for modifying, delete for removing, and options we saw, right, that is used by course, right, to see what am I allowed to do, right? Posting. So the assignment asks you to create, kind of a little UI so that you can post a to do by clicking the post to do, and you create an input field where you can provide the title of the to do, a small description, a due date, right, and a completed. This is using the old version of the to do. Excuse me, the one that has /create at the end, right? So this is misusing that, right? And this is using the new post, right? So that it creates that new to do. Then in the so there's our post to do. And here's our text area, so you can type in a little small description and a checkbox for the completed, right? And then you post it. Deleting, right? We have a delete, right? That passes the ID, finds it, splices it out, and returns a 200. So I'm highlighting this as red, kind of specifying that this is kind of like substituting our previous version, but you don't have to delete it. You can leave it. You can leave it there. Maybe for historical purposes or how not to do it, right? So this is kind of like how not to do this, right? Instead, you would use this instead of that, right? Even though that functionally they do the same thing, right? But one is following best practices and the other one isn't. And updating to do. Okay, so this one we didn't do. So for updates, again, post is for creating, get is for reading, delete is for removing, and then we have put. Put is for modifying, right? And so the convention is to use a put, right here. You can add the put right there, and you would pass in the ID of the item that you're modifying, right, at the end, like that. You parse it out, you find it to do, you modify whatever you need to modify presumably from the body, right? And then you send back a success, right? As opposed to the list, right, of all the to-dos, right? So you send back, yeah, I was successful. And what you do in the user interface is that, again, you recalculate the array, substituting the old item with the new item, right? Right. So in the user interface, right? Here's the async, right? That goes to Axios, does the put. It passes the new to do with the new title, new whatever, and then when it comes back, right? When it comes back, what we do is that we swap out the old to do with the new to do, right? Which we already know how to do that, right? We were already doing that in assignment 4, right? In assignment 4 already you do this, right? But now we're doing it as a result of having done a remote server call, and when it comes back, right, we know that we did something on the server, and we need to replicate it here on the client, right? If there was no error. Okay, extra credit, handling errors. So handling errors, I've demonstrated a little bit of that, and so, for instance, if you're retrieving an item, right, by its ID, if it fails and there is no to do, you respond with 404, right? And this can then be caught on the client using try catch, right? And you can also optionally, you can also include, your little JSON object. You can include a data that describes the error. What happened, okay? So that maybe user interfaces can then display a nice, right, useful error message as opposed to just not found, right? You can pass in maybe a message saying, oh, I was unable to delete the to do with ID blah blah blah, right? So then this JSON object would be available on the client side. Let's see that. So on the client side, Okay, so that was for the delete. Same thing for the put, right? If you're trying to modify an object by ID, but that to do doesn't exist, that would be an error. Right? I would send back, no, I didn't find the to do that you were trying to update. I couldn't find it. Right? So that's on the server. So on the client, we can have a little state variable, right? That captures and renders the error message, right? And then render it, nicely, like a, highlighted like an alert box or something, right? And so now our delete to do or update to do, we can wrap the call in a try catch. See that? We can wrap it, and the error that comes from the server would be passed to us in the error object instance, right? And the data, the message, the JSON object that we sent over would be available in error.response.data. That's the JSON that comes back, which had the message. Is there a question? I'm gonna change it to next week. We're gonna do it on Tuesday, and so I'll probably split it up into smaller quizzes so that I encourage you to come more often to the lectures. All right. Yeah. All right. So let's leave it here. When we come back on next week, we'll start talking about how to work on Canvas and integrate it with a server. All right. Great. Have a nice weekend. Hi. Yes.
So I know on the calendar it says like demo week is the week the 10th.